All right, next up we have Todd Rimmer, who's going to be talking about management scalability.
I want to talk a little bit about some of the scalability challenges that we have ahead of us. We've heard a number of presenters talk about that, so I'll just briefly enumerate that. And then there's a number of key challenges that we have to work on from the management area in OpenFabrics. And hopefully we can all start working together on these, and I'll allude a little bit to some of the things that Ira is going to talk about, and John Fleck about some of the prototypes and work that they're doing right now in some of these areas. So this is just a one-slide refresher. We heard a lot of this from the keynote. We're on a curve that in the HPC community, performance is increasing 2x per year. That's the trend since the 90s. This is translating because it's starting to exceed, it's always been exceeding Moore's law and our ability to deliver compute per socket into rapidly increasing node counts. And the shape of all these curves, whether we look at the size of the number one systems, if we use traditional CPUs, or if we're using many core CPUs, or if we look at the number 10 systems or below, they're all in the exact same shape curves, these exponential curves. This is not specific to HPC anymore. We're seeing similar growth curves in cloud. If you look at sizes of Google data centers and Facebook and Amazon and Azure and other large clusters like that, they're growing at a similar pace. And a lot of this is also going to drive other needs. So the interconnect speeds are limited by physics, and our rate of growth on those has been basically half that of Moore's law. It's been about every 3 years or so that we can see a noticeable bump in interconnect speed. And what that's going to translate into is clusters that are multi-rail, where you've got multiple adapters coming out of each socket or out of each server. And we're already starting to see those kind of configurations done in today's technology, and that's only going to increase in nature. So this is going to mean that the counts in terms of number of HCAs or NICs in a cluster are going to grow even faster than some of these node counts. So the first two big challenges, and Hal's set the stage on the first, is PathRecord query, and the next one coming along is IPOIB ARP. So one of our challenges in trying to implement something like the scalable SA, and the perspective we've been looking at is from the perspective of the interfaces. So if we look at how applications today get their path records, we're going to see that some class of applications and some of the newer written ones are using the RDM ACM. And so that's going through this kind of set of train stops, working its way into the IBSA and the IB MAD stack in order to make queries off to the SA. There's an optional cache in the IBACM that can be used that changes the path, and now you go down an IB verbs-based path to get that information. There's a lot of apps, and especially a lot of the diagnostics and tools out there, they're still handcrafting their path records using UMAD queries, handcrafting the queries, sending them directly via libUMAD. There are some apps out there that have started to use UDQ pairs as a vehicle to avoid some of the security restrictions in UMAD and some of the performance challenges in that path. There's also a fair class of applications, especially many of the MPIs, that are just exchanging lids directly across the fabric during their job launch mechanism, and then handcrafting the path records. These, of course, schemes have challenges when you start to add features like partitioning and quality of service and torus and other details to your fabric, where you really need more than a lid to properly construct the path record. There's other mechanisms out there, some of which are obtaining the information indirectly or directly through IP over IP, and I'm sure there's some others that have cropped up. At one point, about a year ago, I did a search, and there were at least 6 declarations of what a path record data structure was scattered throughout the OFED stack, and that, of course, didn't include third-party implementations that aren't open sourced or might not be available in that stack. And then we look at the kernel. Most of the ULPs, or at least all the ones I checked, are calling IBSSA. So our challenge here in getting something like IBSSA to actually be effective is we have to consolidate all of these different myriad of paths into a common infrastructure so that IBSSA can actually satisfy all these different consumers and customers. Otherwise, we'll see that one class of consumers will get the benefit, but the minute you put one of these apps on that's not using these paths, you're going to have the exact same scalability challenge again whenever that app runs. So one of the real first things that we need to do, or at least in parallel with the work that's going on, is to standardize how we're going to get these from a user space perspective. So there's two efforts that seem like the most logical choices, and they're interrelated, is the work going on in the OFI work group, as well as the RDMA-CM, which is also a key part of the LibFabrics work that's going on. So if we can standardize on using these mechanisms as our user space APIs in all of the ULPs, all the benchmarks, all the demos, all the diagnostic tools, both the kernel and the user space, make sure that the mechanisms and paths we're choosing end up being comparable, and that way everything can benefit from the scalability performance. Otherwise, if we have outliers, we're going to have problems when those applications run. We also are going to need to start thinking seriously about how we want to couple the API. The AFIB is a great start in that as we get to multi-rail clusters, customers may not want to run IPRB on all their rails. They may not want the overheads of ARP or the complexities of configuring IPRB on all the rails. In many cases, at least in the HPC world, they want nothing but compute traffic on those additional rails so that they can get the maximum bandwidth with the least overhead and jitter on those rails. So a lot of what we've been looking at, and Ira and John are going to talk in more detail on, is a plug-in architecture behind the API so that we can have a variety of strategies and approaches so that small clusters where you don't really need the super scalability capabilities can continue to take advantage of the traditional ways of doing PathRecord query. Medium-sized clusters, we can take advantage of caching technologies such as those that are in IBACM. As you get larger, you start to cross into the threshold where things like IBSSA are going to be necessary. And as you get huge, you're going to need to start looking at approaches that are more algorithmic in nature. If you talk to folks that have done BlueGene or have done some of the Cray technologies, they'll tell you that, look, at this scale, they're not looking up tables, they're computing it. There's a direct one-to-one relationship between node number and address in the fabric, and there's algorithmic approaches for doing that so you don't have to communicate all these tables around. And at large scale where the clusters are carefully pre-planned, that kind of mechanism makes a lot of sense and can further optimize things. And of course, by taking a plug-in architecture, and a key part of this is by being in user space, it makes it easy for others that want to research or experiment with a variety of topologies and strategies and techniques to contribute and experiment and contribute to the OpenFabrics efforts. So the initial starting priorities would certainly be getting the direct mechanisms, continuing to have them work, having the IBSSA mechanism that Hal and the team is working on, and then keeping the cache plugin that currently exists functional so that we can move forward then with other approaches afterwards. We have a similar challenge in IPOIB that we need to start really looking at. Smaller clusters can get away with ARP and broadcast, but as you get to larger clusters, the jitter impacts of ARPs and broadcasts get to be a challenge, and you need to start looking at preloading ARP tables. But of course, a challenge in OpenFabrics, especially in InfiniBand, is those tables have to include Q-pair numbers that are not necessarily persistent. So we need to look at how we can solve those problems. And once again, at huge scale, if you talk to somebody at the DOE, for example, or other customers that have deployed large clusters, there's a very algorithmic relationship between IP address and addresses within the fabric and address positions of nodes within the fabric. And so we can explore algorithmic approaches where we don't need to translate or preload all these tables, but rather can algorithmically associate these details that are needed for ARP. But the first step is really also to continue to get into a mechanism where we can have a plugin, have these different strategies, and then let that plugin tie into the path record for the underlying details that's needed. So kind of getting a little bit past those first few thresholds of pain, we've got a number of other issues that are ahead of us that are also going to be points of concern. One of the big ones is UMAD security. So right now the fundamental problem is if you want to use UMAD, you need to have root access. So that either forces you to downgrade the security of your individual nodes by letting everybody access UMAD and opening potential security holes that now applications can go send any random packet they want out on the management interfaces in the fabric. They can go send queries to the SA, try to attack it with invalid queries or volumes of queries and things like that. And so it's too easy a vehicle to attack. So by getting many of these things standardized into APIs that are more at what the application wants to do, instead of telling the app to go hand build the packet and send it out via UMAD, we can start satisfying the customer's needs and start to close some of these security challenges. So we need to get away from telling apps to just go hand build management packets. That's both error prone and has other problems. And it goes beyond just the path records that we were talking about. It includes things like multicast membership and notices and other tools. What we're also seeing in larger clusters is different data centers want to have different policies on how they do security. So they might have an individual that's got the root permissions on all the nodes, and that may be different than the person that manages the fabric and sets up fabric policies. And so oftentimes they want to have the SM and the diagnostic tools run at a privilege level other than root that's more restricted in what it's allowed to do. And so we need to get this separation in place so that you can do that without forcing to run the SM at run the SM at the same privilege level as root, or forcing you to open your entire system up so that you can run the SM at a lower security level. Another big area we need to look through is partitioning. One of the things that's starting to occur is we're seeing HPC clouds being built in other cloud-type environments, in which case multiple tenants are important, and partitioning is a logical solution for those needs. And so one of the big things that's scattered throughout a lot of OpenFabrics are some bad assumptions. If you read the IB spec, it talks about the default partition, and so a lot of apps have hard-coded the default partition and just say, oh, I'm guaranteed to be in this partition, let's go. But if you read the spec very, very carefully, what you'll find out is that the default partition was just a default for power on. It wasn't a guarantee that you would have every node in the fabric in that default partition. And in fact, if you think about it and look at the simplistic little picture, if you put every device in the default partition, the one shown in black, then anybody can talk to anybody. So there's no security. So why even have partitioning? What the real intent in the spec was that the default partition was there at power on. And if you read through the lines very carefully, you can see, well, look, I got this catch-22. So really the only guarantee that makes sense is that all of the nodes are limited members of the default partition so that they can talk to the SA and other management services. And then you can create other partitions on top of this with the right memberships and participation. So in my example here, I've got a red, a green, and a blue partition that may have overlapping or independent participation. They may have different sets of members that are limited or full members of those partitions. And then everybody can be a member of the limited member of the default partition, with the SA being the main full member of that. So we have to start thinking about these kind of details as we're coding things in OpenFabrics, and not just assume that we're going to use PK table entry 0 or 7 or FFFF in our PKey operations, and make sure that we're prepared for these kind of situations, because they're going to be important for multiple tenancy. And so this relates to how IPOIB works and how apps go about doing their queries and interactions. It implies restrictions on how you're using multicast, because you need to be full member of a partition that you're going to multicast to or receive multicast from. And this also relates to IPOIB. IPOIB has got some assumptions that when it starts up, it can look at entry 0 of the table, and that's the P key it's going to use, and it's not really prepared for changes to that entry. Well, that entry may change if somebody changes tenancy on the fabric, or if during the fabric initialization you actually go and put something in entry 0 other than FFFF. Then you need to have IPRB ready to react to that. And so we have some work in progress to try and correct some of those challenges. Multicast is another big scalability problem. One of the challenges is that every node can only do joins and leaves once in IB. And what's going on right now is different apps are calling directly into multicast from different portions of the stack. There's a few out there that are doing things directly. I think a few of the MPI experiments involving collectives have done this approach. IBACM and RDMACM have some APIs here, which we should really standardize around and start using, and then evolve or enhance those if there's needed additional features. And we look at business areas like financial services, the financial services industry. A lot of those are interested in kernel bypass, and those multicast groups may be the same ones as those used for IP over IB. And now you need to have coordination between how user space and kernel space can join the same multicast group once for a given node, and keep track of the membership and the fan out within the node, so that as processes die, you appropriately remove the node from the multicast group, or keep track of the reference count as to how many processes remain using it, and only remove it when the last one or the last use disappears. Okay. Notices are our next big challenge. If you just, the challenge here is this forces a large number of messages to come out of the SM for each event. At small scale, it's not too bad, but as you start to scale up, for example, if you have turn off 100 nodes, which might be a portion of a rack in a 10,000 node fabric, the SM's obligated to send out 1 million notices for all of the get out of service events. It could get worse if you're doing things like node description changes or repath requests and other things. If you turn off half of the nodes in a 100,000 node fabric, you're looking at 2.5 billion notices that need to be sent out to the fabric. So this is not only a scalability challenge, it's also a performance problem for the fabric, because you're essentially taking out a lot of performance on the remaining half to tell them that half the fabric went away. So we really need to look at how we want to do this. The first problem is making sure that we don't have individual nodes registering more than once for a given notice, and make sure we have a way to consolidate it. But the bigger question is, do we really need to use notices, and do we want to go down the path of creating this problem and then having to solve it? Right now there's relatively few uses of notices in the stack, and maybe we want to more carefully consider whether we even want to use and depend on notices, because this mechanism is going to give us a lot of heartburn as we get larger and larger clusters. Another thing that can come out of getting a lot of these services centralized, how we go about getting path records, multicast, and notices, means that we now have the opportunity, by having a centralized interaction, that we can control and pace the interactions with the SA. So we can scale up and down the retries and timeouts based on the size of the fabric and the expectations or the service commitments of the SA or the SA infrastructure and IBSSA, so that we so we can pick the right timeouts. Right now, most of the applications that are interacting just have hard-coded numbers that are assuming some value that worked in some cluster that they did the development on, but those won't always hold true at larger scale. This also allows us to get a little more sophisticated about how we handle busy back-off mechanisms. Right now, the IB spec allows an SA to say, I'm busy, which is a convenient way to say, look, I got your message, but I'm not going to be able to queue it right now. I got too much work in progress. Come back to me a little later. But today, the OpenFabric code just gets that busy, treats it as an error, and immediately does a retry, which is probably the worst choice possible. So we need to be able to take advantage of the busy return to pace the workload. and that way we can have more sophisticated back-off algorithms so that if an SA is struggling, we can prevent the rest of the fabric behaving like a bunch of 2-year-olds nagging their parents, right? So, I think all these problems are solvable. They can all be solved in a timely manner. I think the key is that we recognize and agree that these are going to be challenges that are going to affect us not only in the HPC space, but in the cloud space and other market areas like financial services, and that we're going to need to work together to solve these. Ira's going to talk a little bit in more detail about some of the approaches around centralizing the PathRecord aspect, which directly contributes and helps some of the work that Hal and others are doing on IBSSA. And so let's just make sure we're all committed and understand that we need to resolve some of these issues so that OpenFabrics use can continue to grow and meet the needs of the evolving data centers and HPC communities. So the keys are that, the clusters are going to grow. I mean, there's so much evidence. We heard about it in our keynotes. We've heard it in so many presentations. We got a number of issues, many of which are really coming to the forefront now that we really need to solve them. I think they're all solvable, and it's just a matter of us committing to work together to solve these. Any questions? Sure.
So one of the things I did see that's an issue, I think, for us was the permissions around FAP registration. So we, right now, anybody can do it, and so on the system sometimes we'll see, some nodes or something that have registered for like all kinds of stuff, and we're like, well, who did that?
Right.
And so we really kind of want permissions and security around FAP registration too, so it's sort of another complicated management.
Right. I was notices and traps, I think, are very much the same interrelated thing. So yeah, I think we need to, because that's the problem. If you get an interesting app that comes up and says, hey, I'm going to register for this trap, and oh, by the way, I've got 100 instances of this app running on each node or on a large set of nodes, now you've got this huge scalability challenge that can add up to millions of messages every time that event occurs. And do you want the jitter of that on your fabric? Do you want the overhead of the SM going off and generating 1 million traps instead of doing something else?
Actually, I've got a question for Bob. You said notices. Would you like security around multicast registrations as well?
Sure. So all of that stuff,
You want it all and you want it last week?
Well, so you want some administrative control over it, so it's not that you want to prevent it, you want to be aware that it's happening.
I see.
Right? Because we have on our system, 1,000 people doing stuff, and there's OEMs with software packages, and so they're, and we're installing a lot of this stuff, maybe not knowing what actually is going on, what sort of software services or network services that the packages are using, right? And so we really want to have controls over what access those things have and be aware of them and enable them or disable them based on what makes sense. Because right now it's pretty difficult to track back exactly who did it, what's the package that's doing this. And yeah, multicast is another one. We want to disable that in most places, especially the IPv6 stuff. That can become prodigious, right? So there can be a lot of overhead associated with that. So just any ways that we can reduce management overhead, because since we have scalability problems already, there's a lot of extraneous things that happen that we can turn off to improve, work these sorts of issues. Right?
Yeah, the IPv6 multicast is another good example. The stock Linux stack, every node registers for a unique multicast address, the node solicited multicast group, and relatively few, if any, applications really use it. So suddenly you got this burden of creating 10,000 multicast groups in your fabric that are probably not used at all. Yeah. And every time you bounce a node, it's going to go rejoin or recreate those groups, and there's going to be like one member of each of them. Other questions? Yes.
So, are we seeing new problems? Is this a new problem because we have 1,000 node clusters, or there are similar problems in other computer science areas like graph theory which are already solved? Or another question is, if we are not using InfiniBand, then don't we have 1,000 node or 10,000 node clusters with other networking technologies? And if so, they might already have solved the problem.
Right, so just to repeat the question, if I got the paraphrase right here. The first question is, are these new problems, or are these just occurring because we've started to build many thousand of node fabrics with InfiniBand? And the second question is, are these problems unique to InfiniBand, or are these perhaps problems that have been solved in other networking technologies? So the first half, I think these are all problems that we've been aware of. Many of these I've mentioned in some previous talks. It's just now with that exponential growth curve, we're prime in about ready to hit the vertical part of that curve, and in some deployment examples and industries, we're already pretty far up the vertical part of that curve. So now, it's imminent and near term, whereas 3 or 4 years ago, it was like, well, in 3 years we might hit this problem. I think some of Bob's comments are showing he's he's on the vertical section of that curve right now. Other technologies, yeah, I think there's some things that have been solved in other technologies. I think some of these are still challenges in other technologies. Some of these we've created for ourselves, in that things like Q-pair numbers are a component of the IPOIB. So we have an ARP problem that's a little different than what was been able to be done in the Ethernet world with static ARP. We have the PathRecord resolution factors, whereas some other technologies can get away with things like DNS and ARP. So some of the features that have enabled the extremely low latency and the efficiency, for example, in InfiniBand, were done in a different way in other technologies. So some of these problems are unique to the InfiniBand environment, but some of them are side effects of trying to get that super low latency and those additional controls. Okay, well, thank you very much for your time today.